Hi, you are listening to Climatic Scale, a podcast about what it really takes to scale climate solutions. My name is Aneri Pradhan, host and co-founder of Climatic Group. I am joined today by Annie Wexer, who is the Director of Investor and Partner Relations at Nyobolt. Welcome, Annie.
Thanks, Aneri. Very happy to be here.
Absolutely. And what I'm so excited about that Nyobolt is a company developing ultra-fast charging battery technology for high performance applications. And so in this episode, we'll talk about the journey from breakthrough technology to landing real commercial pilots and what it takes to turn technical advantage into market adoption. And just wanted to share with our listeners that Annie and I actually met at the Startup Energy Transition conference last year in Berlin, and it's also coming up again in March. And Nyobolt won one of the awards. So I heard her pitch and it was amazing, and I knew I had to get her on this podcast.
Yeah, thank you so much for the invitation. And I'm excited to tell you about some of the new innovations and sectors that Nyobolt is getting into. At the SET Tech Festival last year, I was presenting our mobility and transportation, fast charging technology. And today I'll give you some insight into more of our robotic and AI power systems that we're really excited about.
Awesome. So, Annie, for listeners new to Nyobolt, what problem are you
Mhm.
solving?
Yeah, so Nyobolt, what we're doing is we're solving high power, ultra fast charging, long cycle life challenges for an always on world, which today is powered by AI. So we're seeing power requirements for industries such as robotics and data centers, even commercial transportation, which are operating 24/7. And the old age of lithium ion batteries with long range, high energy density, but really low power density, where charging is taking hours rather than minutes, doesn't work for this new age of 24/7 operations, high uptime that requires a lot of power and fast charge capabilities. So we identified this gap in the market about 6, 7 years ago, and we've been working really diligently to really serve that segment ever since we were founded in 2019.
Amazing. And why is fast charging and high power performance such a critical challenge right now?
Yeah, so some of the industries I mentioned that are powering our day-to-day life, warehouse operations to get your next day Amazon delivery, for example, they're under a lot of pressure to operate 24/7. So that's either pressure from consumers demanding nearly instant delivery of goods. That is demand from the AI space where hyperscalers are needing to operate these new next generation data centers with the latest GPU chips at 10 times or 20 times the processing power that was needed just a few years ago. And so these types of industries are looking for not just small innovations or step change in battery and power technology, but really a new paradigm shift. And so it's really a race to market for some of these new innovative technologies to help solve those 24/7 uptime industry challenges.
Yeah, and what led to the creation of your boat? Could you share its founding story and when the technology moved from lab scale to market?
Yeah, happy to. So Nibel was born out of the chemistry lab at the University of Cambridge in the UK, led by our co-founder, Professor Claire Gray. Claire's lab was developing novel nanomaterials that had extremely fast charge characteristics with a very low impedance, or basically temperature increase. And when you have a very low temperature increase when charging batteries at high rates, that allows them to extend their life cycle. So we were getting all these great USPs out of the material science for batteries, but what we needed was then to apply that anode material innovation into battery development and a full system level solution. So Claire teamed up with our other co-founder and CEO, Sai Shivareddy, who's an engineer by trade. He had worked a number of years in supply chain and mining and battery systems, and they teamed up to bring Claire's anode innovations into a full system approach. And so that is a fully vertically stacked battery power system from anode materials to battery cells to modules and packs, including all the power electronics, software, battery management system that you can deliver in a nice clean package to the end customer, whether it's a robotics customer, a data center customer, an automotive customer. And that was how we formed Nyobolt under that realization that we had really novel material science technology, but we could package that into innovations at the cell level and the pack level to deliver a full system that had 10 times, 10 to 20 times really the power capabilities, long cycle life, extremely fast charge characteristics that this end customer we had identified really needed. So that was the lab to business transition that Nyobolt made from 2019 until today.
Amazing. And the team was quite technical and amazing scientists. What was the biggest shift the team had to make to think more about commercialization?
Yeah, so we started, like I said, in a lab, in a material science chemistry lab, basically. But we knew to build that full technology stack, we would need seasoned engineers who had built power systems before, power batteries, power systems before. So what we did was we quickly identified, one, where were the geographic hubs, tech hubs in the world, and where could we find the talent that created innovations in this power space before. One area was, of course, our backyard in Cambridge, UK. And we hired an amazing team of mechanical engineers, electrical engineers, software engineers who had built battery systems, power systems for Formula One and high performance automotive like Mercedes AMG. So that was a great team to hire on the applications engineering. So basically to develop those modules and packs, the end product for customers. On the other side of the equation, we needed a team who had experience designing, developing, and prototyping power cells, so power battery cells. And we found a team in Boston, Massachusetts, in the US, who was coming out of a power battery company that was going under. And so we were able to hire almost the entire team, get access to a lab with state-of-the-art equipment. And because we had the material science, the anode R&D team already in Cambridge, basically between those two locations, we had the full vertical stack, the materials, the anode materials, the battery cell engineering capabilities, and then the applications engineering capabilities. So even to this day, we have a very rapid design, development, and iteration process between those teams because they're all under the same umbrella. They're all part of Nyobolt. We all have the same targets and mission alignment, and we can make changes either at the material level, the cell level, or the modular pack level to get the intended results that the customer needs for their specific duty cycle, power, or energy requirements.
And you mentioned there's so many use applications for this technology. How did you decide which markets to enter first when the technology has a lot of use cases?
Yeah, we generally follow customer demand, especially being a young company, a young unknown company in those early days. And we've been very fortunate to have our first customer come out of the Boston area in the US. It's a robotics customer. And we've had a number of customers in the automotive mobility sector, both in Europe and in the US, approach us. And we've built quite a strong pipeline between those two continents. But I would say when it comes to the AI data center, innovation and speed of innovation, we find that to be strongest in the US right now. So a lot of the AI data center projects we have are focused on, let's say, US customers, but we're not limited to that. It's really, if we're able to solve a critical customer problem with power, uptime, fast charge, we're not geographically limited, but it has to be a good match for both the end customer and for Nyobolt. And so at the moment, that's primarily between Europe and the US.
Okay. And I remember when we first met, some of your pitch, you mentioned that one of your early customers actually reached out to you. So it was inbound. Can you walk us through how that happened from inbound to pilot, commercial pilot? And what were the steps that Nyobolt took to secure that commercial pilot?
Yeah, happily. That doesn't always happen. We wish it would happen more. Most startups would love for a great customer to just land in their website, contact us form. But that's
Right.
exactly what happened. We built a proof of concept EV that could charge in 5 minutes.
Yes.
And we revealed that EV to the public at Goodwood Festival of Speed in 2023 in the UK, big automotive festival. And it was after that. So that picked up some press, 5 minute charging EV. That picked up some press, and we really got an inbound lead form through our website from this robotics customer. And they said, we have a problem with our warehouse robotics. We're using a technology that has extremely fast charge capabilities. It was an ultracapacitor, but not enough energy, so therefore not enough range to complete tasks all around the warehouse. And so we need a new technology to deliver not only fast charge, but also enough energy and range to complete the jobs that these robots have to do, whether the footprint is small, medium, or large. We have a number of different warehouses, different layouts, and our current solution just isn't delivering the output that our customer, which is a very large retailer, expects. So they had a pain point. They needed really a step change in technology for their robots. And they saw that Nyobolt, even though we had revealed our technology for an EV, very different application, they had that forward-thinking, innovative, first principles mindset to come to us and say, hey, we think you could apply your technology in an EV into a robot. Let's work together. So it takes a certain type of customer who has that startup mentality, that innovative mentality, because many customers, especially in automotive, they're looking for tried and proven technologies because, of course, that's quite high risk to take a chance on a startup or scale up tech company when you're talking about not one or two products, but you're talking about tens of thousands or hundreds of thousands or millions of vehicles or robots all around the world. So we were very lucky that this robotics customer approached us. And there were a number, like you said, there were a number of steps we had to go through to really prove ourselves as a company, prove that we had the expertise, the engineers that could design a pack, met or exceeded all of the customer's performance requirements. And so we went from the material science validation, the testing data, we went through cell level testing data. And luckily, one of the really great initiatives our battery team in Boston had done was years prior, when we had our very first prototype battery cells, they decided that they were going to start putting these battery cells on cycling machines, basically charge and discharge thousands of times, hundreds of thousands of times. And they started that preemptively before we had any customer asking for that data. And by the time this robotics customer came to us and said, okay, we want to see your test data, we want to see some performance data, we could demonstrate a fast charge of the cell, no problem. But we could also show them hundreds of thousands of full charge and discharge cycling data over a multi-year period that said, hey, we're very confident that our cells not only can deliver the fast charge requirements that you have, but can keep your robots in operation for years, over millions of cycles. And that was a really critical KPI for the customer because obviously it's expensive CapEx if you have to keep replacing robots or keep replacing the power system with conventional lithium-ion battery technology that isn't equipped to handle those high charge rates and it won't last for millions of cycles. They might last for thousands of cycles and then they have to be replaced. So it's a combination of a number of different things, right? As a startup company, we had to anticipate what customers would expect from us in terms of having proven milestones, proven technology, data availability. And then once the customer came into this development cycle with Nyobolt, we had to work together to design product requirements, design timelines and milestones that we agreed to hit as an engineering firm. They, as a customer, then had some requirements to test and validate that each of those design and development milestones were in fact passed. suitably, and then we can move on to the next design development phase, et cetera. So we repeated a number of those design development, test and validation phases before we even got to a level where we were ready to certify the end product. So certifying the battery cell, certifying the pack with all of the power electronics and software embedded. And those two things are done at the manufacturer level. So you have a third party manufacturer coming in that is really stress testing your technology. So you have all these levels of test and validation, one under Nyobolt, two under the customer, and then three under the contract manufacturer. And so by the time the end product is certified, you have a high degree of certainty that product is going to perform as expected out in the field. And that whole process took about 2 years and required a lot of dedication and diligence on Nyobolt's side, right? We had to say no to a lot of other projects, a lot of other customer projects to stay focused and deliver for our first customer. Because if you don't deliver with your first customer, you may not get a second chance, right? This is the sort of the rule of the game in the startup world. You don't get a lot of second chances, maybe never. So we were laser focused with our first customer to really prioritize their needs, exceed expectations from design and development perspective. And the customer, thankfully, was on the same journey with us. They had such an important pain point that they had to solve that they were equally focused, equally diligent on working on us to hit those pretty aggressive development milestones, do what they needed to do to test and validate each prototype so that we could make the revisions that were required and get to a certification and start a production phase, which we really, I want to share the good news, we hit last quarter in Q4 and started commercial scale production and deliveries for that customer. That's one customer example of how that works. But for us, being the first customer, it was extremely important and an excellent case study for how we would approach the second and third and fourth customers following.
Yeah. Oh my gosh. That was so interesting. And I loved how you laid out all those steps. And one thing you said is I think a lot of startups might find hard to do what you did, which is to say no to other inbound requests to focus only on your first customer. And just, was that a tough thing to do? Or was everyone just so laser locked in, all resources on your first customer that there just wasn't the bandwidth to work on other inbound requests? I'm just curious, like thinking of other startups out there, how they should strategically look at that.
Yeah. And to maybe clarify, we didn't say no to all other customers. We brought in 2 other customer contracts during that time, one in heavy duty line application and another one in a humanoid robotics application. It wasn't we said no to everything, but we were very, very disciplined on how we evaluated customer requests. And so for us, and possibly for other startups in this deep tech field, which are very CapEx intensive and labor intensive, is we started with a funnel. So as the customer leads come in, we first identify, okay, what is the problem you're trying to solve? And for us, we have this very, I would say, narrow focus with a very wide application. But the narrow focus is we're looking for 10x to 20x power requirements to what exists on the market. We're looking for long cycle life, meaning industries that are running 24/7. So they have multiple charge and discharge cycles every day, maybe hundreds of charge and discharge cycles every day. So they're putting their systems, or they're pushing the limits of battery technology that exists on the market. And for us, that's our perfect sweet spot, right? Because we can deliver products with these power performance, long cycle life performance attributes that traditional lithium ion cannot do. And so if we're approached by a customer that just says, oh, we want a 10% increase in our charging performance, or we want not step change innovation in their power and energy solutions, but slight improvements, but without too much of a cost increase, that for us, we'll take on those projects a little bit later down the road. For us, the earliest customers we want to bring on are the ones that have the biggest power problems, the biggest charging problems, because that's where we know we can make the most impact. That's what really changes the game for their industry and for their end customers. And so we want to make our customers look good. We want to make them win with their end customers, like we did with our our first robotics customer. And so we said no to a lot of projects where it wasn't really a step change in power and lifecycle performance. And we decided to say yes or prioritize projects like this robotics customer who had a problem that one, our technology could solve. We also didn't want to overpromise to solve every problem. If customers really needed a lot of range and energy, and maybe that's not our number one USB. We're very good on energy and range for sure, but we're even better on power. So we always wanted to prioritize customers who are also prioritizing power performance and then who had maybe a CapEx and total cost of ownership concern. So when you're talking, like I said, about thousands or tens of thousands or hundreds of thousands of applications, whether it be robots or something else in your fleet, that problem increases exponentially with the number of bots you're operating. So we're looking for the bigger the problem, like the better the customer fit for us at this stage. So we took the approach to focus on a smaller number of customers, design, develop bespoke solutions for these first customers. We go through that design, development, iteration phase in a very close relationship with those customers to deliver maximum impact for their business. So that's where we're at today. So we say yes to a small number of customers where we can make a high impact. I think that's how I would summarize it.
Okay, thank you for going into detail on that. So how do you define success upfront with the customer, especially since your technology is very impressive? So they probably have very big visions. So how do you define success?
We're careful to, let's say, celebrate our successes once we have data and feedback from the customer that our product is helping them to do their job better, more efficiently than it was doing previously with the incumbent technology. And so that might take, like I said, in the case of our first customer, that might take 2 years before you can really celebrate. But what you gain from being diligent in that design development phase is once you see your products in their robots operating in the warehouse and they validate, and this customer said this publicly in a press release and on their earnings call as a public company, they have supported our claims that we're enabling 6 times the uptime, the energy and uptime as their previous solution. We're helping them to increase the whole uptime operation of their warehouse. Their end customer, which is the largest US retailer, is extremely happy with the solution and wants more of the bots rolled out to more warehouses. So that the data points and the feedback from the end customer is how we define our success. Have we solved a real world problem with our technology? Because we can get the amazing statistics from our lab test. We can claim the 5-minute charging of our EV with our own lab tests. And some of those demonstrations are very important and useful to attract investors and customers to come to you and say, yeah, that's a great statistic. We want to learn more. We want to see for ourselves. And this is true. But really, once you get the customer delivering the data points and the positive feedback, that's really when we celebrate our success.
Yeah, that's the best. The best outcome is their customer tooting your horn versus yourself.
And I think I give credit to our CEO because sometimes you get marketing teams, you get sales teams. We really want to talk about every small win we've had. We want to put a press release about this. We want to talk on LinkedIn about all these great things we're doing. And we kept a pretty low profile for a number of years. We released the 5-minute charging EV and then a 4.5-minute charging EV the second year, which was important to show ourselves as a leader in the high power fast charge technology space. But a lot of our other achievements and innovations done in the lab, we were very quiet about that until we had the customer speaking on our behalf about the product and the innovation. It's always nice to break out into the public sphere with a lot of positive news versus going out too early and tooting your own horn and then maybe not delivering everything that you promised or you said that you could deliver. So I think our approach has been quite pragmatic and nice to have the positive feedback when it was proven and the success really could be counted.
Yeah, that's awesome. So you mentioned that, especially in the internal capabilities, you have an extremely big engineering team. And where do you feel the internal capabilities really helped set you apart in working with these customers? Was it the engineering? Is it the responsiveness? Is it the communication? Maybe it's all of the above.
It's all of the above, but I will say the engineering capabilities, I mean, we're 120 people globally, and the vast majority of that talent is engineering, whether it's battery engineering or applications engineering. So we're very engineering heavy. We don't have a lot of, let's say, traditional corporate functions, right? A lot of those corporate functions wear many different hats, from project management or marketing and communications or investor relations. We really keep the focus on the engineering excellence within the company. And what that does in building the reputation and the trust with our customers is we put a very experienced, very dedicated team of engineers, both battery and applications engineers, on the working group together with the customers' engineering teams. And they work together, daily meetings, oftentimes in person. And that helps because we have a Boston team and this customer is a Boston team, but they work almost as one team for the period of joint development. In our case, it was about 2 years, and it's ongoing because there'll be next generations and V2 and software developments that are ongoing. So we work almost as one team with the customer's engineering team. And so not only do you bring engineering capabilities and support, but you bring that responsiveness, you bring that strong communication, and that builds trust that, hey, we're really on the same team. We have the same end goal to help you, customer, succeed in your day-to-day operations, succeed with your end customers. And if we do our job, it will make us look good and will help Nyobolt get more customers. So I think that's been a really unique and critical part of our business strategy, is having the engineering capability really integrated with the customers' engineering teams.
Yeah, and very much hearing it's an engineering-led sales team, which is great. But when you are also now in the process of moving to multiple customers, do you see operational changes to, you still can retain the engineering kind of mentality as a culture, but do you see other operational changes that are really necessary to start meeting the needs of multiple customers?
Yeah, for sure. So we definitely have grown our commercial team, and we've hired a very technical commercial team, a team that can go out and, like I said, we have this sort of inbound pipeline or filter process, right? So it requires a technical commercial team to take those inbounds, go to conferences, do the outreach, speak with customers in a way that they can disseminate the information to understand, okay, is the customer's problem one that we can solve with our existing technology? In which case that joint development process might be quite rapid. We might be able to deliver a product at cost, meeting all the performance expectations in a short period of time. Or does a customer's need require a lot of custom development? Does it require new cell designs, new pack designs, new software controls that we haven't developed before? And therefore, that would be a more expensive, more resource heavy type of project. So the commercial team really helps our engineers by vetting out possible customer projects and bringing to the engineering team really the ones that we think are going to be a good fit for us technically, and where we have the resources to put on a new customer project. I would say those are the two, that's the area that we've grown probably the most in the last year or so. But we've been really disciplined about our growth. I think we've had about 120 people since I joined nearly 3 years ago. So you lose some, you hire some, and you transfer some of the skill sets based on what the company needs at each phase. But I think that pretty much sums it up. We'll definitely be a very engineering-led company, being in the B2B space. But obviously, having your marketing and your comms and your investor relations and your commercial team are really important, because you could have the best technology in the world in the lab or embedded within a customer's product, but we don't have a product that's sitting on the shelves in a retail store that
Mhm.
consumers can see. So you do need that public voice that can tell the world about what we're doing, and that helps to bring in more customers, investors. And so you need a balance, but I would say, yeah, we're definitely very, very much focused on still being engineering, design, development, and manufacturing for the foreseeable future.
Nice. And what are your priorities for the next 12 to 24 months?
Yeah, so we have, I keep mentioning like this word disciplined, right? We've been very disciplined in the number of products we've developed, the number of customers we've taken on, so that we can deliver excellence in each of those verticals and each of those products. So for the next 12 to 24 months, we are really doubling down even more on the AI, robotics, and warehouse automation space, because that's our first proof point. We've had a lot of success there. We have a very happy customer. So we want to do more in the robotic space. The second vertical that we've really been working to enter in a big way is the AI data center infrastructure space. So we have a really amazing product we've been developing for about the last year, which is using the same exact building blocks, the same materials, even the same cell that we use in robotics, but in a data center rack that is a power rack. We call it dynamic response system that can sit within the rack within hyperscalers data centers right next to the GPU. And it can be an additional power source that can help to support the power requirements from the grid when the GPUs are in training mode. So think of having thousands or tens of thousands of GPUs all turning on at the same time to help train the AI models. And that requires 10 to 20 times the power from the grid as when it's in standby mode. And those power fluctuations are really problematic for data centers. Problematic for the grid, problematic for the data centers. And so our battery systems can sit in a really slim rack, and they can help to buffer those power spikes. So we can deliver that extremely high power, fast response power during training mode. And then when the GPUs are not in training mode, almost, let's say, dormant or in standby mode, we can be quickly recharging back from the grid. So we help to buffer fluctuations in power within the data centers. We also have enough energy density to act as a backup unit if the data center has a short outage. So this is the newest and latest product where we've had very rapid product development using our existing technology stack, but it's a new vertical, it's a new set of customers. And so we're now in that stage where we're working to get that product out of the lab and into customers' data centers and start that testing and validation cycle that I mentioned with the robotics customer. So we've done this before. We're very confident that everything we've tested and proven in the lab can be done on the customer site, but the customer participation is extremely important to prove that the technology works in a real life environment. So that's what we're really excited about. And so those two programs, I would say primarily, are our focus for the next 12 months. Next 24 months, we hope to see more in the mobility and transportation space, especially in the heavy duty, more 24/7 operations, medium, heavy duty commercial vehicles, mining trucks, again, fleet equipment, port equipment, all those really heavy duty applications that have had a hard time electrifying because they're heavy. They can't afford to take hours to recharge. They need to recharge in minutes and get back to work. So we do see mobility becoming a bigger focus for us, so probably over the next 24 months. But I would say the next 12 to 24 months, very heavy on the AI, robotics, and data center space.
That's so cool. I bet you must have so many major tech companies knocking on your doors about the AI data centers at the moment.
It's a hot topic.
Yeah, absolutely. Annie, thank you so much for joining Climatic Scale. I think it was really fascinating, and it's such a hot space that you're in. And thanks to our listeners for tuning into Climatic Scale. You can find our other episodes on climaticgroup.substack.com, our website, on Apple Podcasts and Spotify. Thanks, Annie.
Thanks, Anari. Have a great day.